Hello guys, this tutorial came up unexpected and recently. Basically it's functionality that will help you to translate mouse position inside your widget as the local space of your texture or UV. It can be used in many options. One of these is actually the minimap and the sectors, the one you saw from the demo, and it's fully procedural. The size of the grid and the position that we will translate is dynamically changed, and everything works without any flaw. So let's get started, and here you can see it's the whole material. This one is leftover that I'll show you why I left it here. So as you can see, this one is my widget. It's simple image with the material applied over the brush, nothing fancy. Here is functionality for the sake of the demo. So on mouse enter, I check whether map image is hovered. If it's so, I start timer, so it will be checking mouse position. If mouse left the map image, it should clear the timer, so it won't be tracking my mouse. And this one is actually the functionality. So from map image we get dynamic material, this one over the brush, and as you can see I have the PR function which is called mouse to UV, and it looks like this. We get cached geometry from our widget, then get local size and put everything inside local to viewport. So as you can see from the description, it translates local coordinates to geometry provided into local viewport coordinates. Next we need to somehow get our mouse position. For this one we use get mouse position scale by DPI. Make vector, or we have it one. Then we subtract from top our bottom logic and divide everything by the local size of our image. This one will return the UV, but because like mouse position is 0, 0, and here we have on the top, on the bottom right corner 1, 1, but for the widget it's actually inverted, and that's why this one will return opposite direction. So our 1, 1 will be on the top left corner and 0, 0 on the bottom right. I'll show you. Let me just quickly print here the results. So if I launch the game, you can see here we have 1, 1, here we have 0, 0. So not to mess around with the UMG logic, because this approach is for manipulating the UV space of the texture. I have custom rotator inside my shader, so I don't mess around with the UMG logic more. I only need to rotate it on 180 degrees from right to left. That's it. So we have our UV. Here on the track mouse I set vector parameter on the dynamic material with the it's linear color, but I only need 2 coordinates. And as you can see, parameter is called UV. So here inside my shader I have UV. It's this one attribute that will be actually changed. Next thing is to make it work, so you will see the results. Also I do have here override of the function on mouse button down. It's simply play animation, the one you saw from the demo, and nothing else. So it's like the checking from if we select something, we change our color from white to green and back to start again. So let me show you one more time this one, so you can copy it in case you want it. Now let's talk about our shader. So we have our UV, and we need somehow to translate it to work with our grid. So as I said earlier, this one is custom rotator. So we are rotating our whole vector, this one, on the 180 degrees, because this one works with the values of 0 to 1. 0.5 is actually our 180 degrees. So what will we receive if we don't have this one, but have only this one? If we use UV and mask out each channel, then we subtract particular value, append everything together, we'll receive actually the coordinate space. Here I also have generated round rectangle. It's the simplified version of this kind of logic. And with the help of this, I can actually get the outline of my selection. Of my selection, my rectangle, my sector. But it can be used like this one, and this will return. Let me show you the whole shape. So, and probably I should start with this one, this graph, and explain you everything. So once we have texture coordinate, we subtract something to make the shift on the left or the right for each channel. Then we use abs or absolute. So that's how we can get, let me show you. We have this kind of gradient, and we can use this as the selection panel. So we receive our UVs, and then we actually check whether conditions done here will help us to see at which particular coordinates on the red and the green channel we are. And with using the sign, we actually withdraw everything but this one. So this black mask means that we are actually at the center of our coordinate space. So if it was like 0, will be at the end, and if it's 1, at the beginning. 0.25 here, 0.75 here. The reason why it's opposite from the one you probably used to, that's because we have this custom rotator. So, and we need somehow to calculate this one. It's our x and y, so that's why we have other calculations here. And when we add everything together, this one and this one, will receive the actual sector or the space where we should be located. Then we actually 1 minus everything, invert, so that's our mask. So that's how it works, but we can omit it and use this one instead. This actually can have more pretty results. So how to get the gradient with the fixed step? Everything is actually quite obvious. We need to multiply our UV, round and divide it by the same number, so each kind of step will have the equal division, the equal distance from each other. So then let me continue maybe with this one for the moment. I'll actually go with here. Let me check whether it's all right. Yep. So now if you take a look, and if I leave everything maybe like this one, so we only have our coordinates. Yep. Now, as you can see in the preview, we are at the center. And if we start moving, everything moves smoothly, right? But not at the particular sector, the particular rectangle. So we need somehow to make it work with the fixed step. So it's not so smooth, but it should not be. For this, we use these calculations. We have our UV, and we need to get the same logic as we have here, but for our incoming UV, for our coordinates. We multiply floor and divide everything on the red and green channel, our X and Y, with the same step. So grid is here, same as here. And from our UV, we should subtract the incoming coordinates. You can also see here that I have sort of shift. By default, if you take a look at what we receive at this mask, let me show you. So we have round here, but you can mention that our left and right bounds are actually not the same size as all of our other gradient steps. That's because we have round here. If we take a look at the floor, you'll see that this one will return actually unequal size of the center one. That's due to the apps, how it works. So that's why I use round to get proper area inside the center. And I need to have this sort of calculation. It's the switch, because if you have the grid of 10, it means that we have 9 equal parts here, but 0.5 on our side. So we need to have 1 divided by the number of grid and divided by 2, because we have 2 sides. So 1 divided by 10 will return 0.1. And 0.1 is actually the calculated or whole number of the whole segments that we have on our side. So that's why we divided by 2. That means that on the X and Y we'll have this kind of half offset. So if we add it to our formula and calculate everything, you will see that 0.5, 0.5 now is at proper position. Without it, it will be somewhere at the center, like this. And this one is grid independent, so if we go with 4, you can see everything is changed, and if I launch it, you'll see that everything works also fine. Nothing happens. I actually go inside this one and it will return proper one, like this, this, and this. So that's how it works. And now about the grid. This one that we have is sort of our navigation grid. We use this kind of calculation. So texture coordinate multiplied by number We mask out each channel, use cosine or sine, subtract the width, actually width of each line, seal and saturate, so we'll receive the equal parts of our incoming grid, add everything together, we'll receive our grid and multiply by small number to change its opacity. Then simply go to the blend mode with our selection. Our grid will be our base, and use our texture here. So that's actually the whole result, the whole logic. And now it looks like this. It works perfectly. And I'll guess I'll leave this one as the free code share, because I know some of you guys struggled, and I also struggle once I need to have the proper realization of mouse to UV space, particularly in the UMG. So how to get this grid? It's actually quite simple. Here we append, because it's our R, it's our G, and if we append everything, we will receive the UV space. Then we have 1 divided by the grid to set the box dimension. So it will be the same ratio as our grid here. So if you go with 10, you'll see it works fine. And here you can play around with these values to get different results. And to get the actually selection grid, you only need to frag of this result. So this one, if we take a look at without frag, you will have the whole selection here, like this. So I hope you like this tutorial. I have Discord, I have Patreon. In case you want to support me, please go there, and see you soon, guys.